One presentation I gave before was about the operating principle of a flyback converter. I presented it during a small engineering discussion session, and the audience consisted mostly of undergraduate students who were just beginning to study power electronics. Because many of them were not yet familiar with switching power converters, I realized that a purely technical explanation with detailed equations might be difficult for them to follow. To engage the audience more effectively, I adjusted the purpose of my presentation. Instead of focusing mainly on mathematical analysis, I focused on helping the audience understand the physical idea behind the flyback converter. I first explained why power converters are needed, such as converting high voltage to a lower and stable voltage for electronic devices. After that, I introduced the flyback converter by describing its basic components: a transformer, a switch, a diode, and an output capacitor. Rather than immediately discussing formulas, I explained the energy transfer process step by step. For example, when the switch is turned on, energy is stored in the transformer's magnetic field. When the switch is turned off, the stored energy is transferred to the output through the diode. I also used simple diagrams and animations to show how energy moves through the circuit. These visual explanations help the audience understand the concept much more easily than equation alone. In addition, I asked audience simple questions during the presentation, such as why isolation is important in power electronics. This helps keep them engaged and encourage them to think about the system. Through this experience, I learned that understanding the audience's background is essential when explaining engineering concepts. Even complex systems like flywheel converters can become easier to understand when the explanation focuses on intuition and visual reasoning.